Welcome. This is a quick demo using the Security CoPilot to investigate a Sentinel incident. My name is Wayne Burke. Sit back, relax, and let's take you into the Azure cloud environment. We're going to be using Security CoPilot to investigate an incident in Sentinel. And a security incident by the name of John was tasked to investigate incident ID 255 on Sentinel. John proceeded to both the Sentinel and Defender XDR portals to look at the actual incident. And if we look at the incident summary, John effectively needs a quick overview of what happened in incident ID 255, and then further asked CoPilot for assistance. The result was CoPilot provided John with an understanding of the incident background with findings. If we look at the script analysis, John does not understand the suspected malicious script that was run and asked CoPilot for assistance. The result, CoPilot was able to dive deeper in with an explanation of the breakdown of the suspected script run. And then John was not well versed in using KQL language, your Cusco query language, right? So they asked CoPilot for more assistance. The result was he was given all the needed KQL queries to assist John to search for the intended results. Then John needed to write the report. So an incident assessment, a set of recommendations, and obviously what to do next. And of course, he got the assistance from CoPilot. So we're going to be looking at going through the triaging, starting off with phase 1. So this is the Sentinel portal. And we're going to go ahead and click on incidents under the threat management. And there we're going to go and search, as you can see, by ID, title, tag. Here we're going to go and search by ID 255. And there we can actually see the title. We're going to click on the title. You can see this was a power met detected on one endpoint. And we can now click on the investigate in Microsoft Defender. So really utilizing some of these tools to augment our abilities really helps us to increase our capabilities of doing triaging, where we're not replacing ourselves, we're just augmenting ourselves with AL, or artificial intelligence and machine learning. So here we have the use of CoPilot. As you can see, CoPilot's automatically generating the summary for us. So there could be a guided response, obviously no actions to respond. But we obviously want to investigate this further just to go and double check, because if we're looking at state-sponsored types of attack vectors as an example, well, you might not get all the right triggers that lead you down the right hole, so to say. So here's a quick CoPilot incident summary. You can see it was summarized so quickly for us. The detection, the incident began giving the specific date. The suspected service was detected on the device. An active power met piece of malware, malicious software, was detected in the command line on the same device, and then Defender prevented the execution of that malicious piece of code, and then finally the incident concluded, finished up, and Defender again prevented the execution. So when it attempted that attack again, it prevented that, at least Defender did. So you can see how efficient this really is. Now we're going to dive into the script analysis. So we're going to click on the various different types of alerts now, and we're going to go ahead and dive deeper into this with a nice visual, as you can see, your incident graph, and then we're going to go through the actual process, the steps that it actually took for the actual execution. And you can see this is just amazing that we've got everything in a very, very clear interface. You can see the exact command lines that we used. Now if they had obfuscation, like they've got PowerShell obfuscation, you can actually see it has the ability to decode a lot of the obfuscation tactics used by malicious hackers. And then it's further now generating analysis based on that one specific incident alert that we can then dive specifically deeper into that active PowerMet malware. So that's where you can see Defender prevented the execution of that malware, and we able to triage with diving deeper in to looking into the actual code, the script analysis now where CoPilot, even if you're not a scripter, CoPilot's helpful in that it's going to give you in layman terms, okay, this is technically what happened, which means it did XYZ as an example. So it's elaborating further without necessarily having the latest and greatest of up-to-date coding skills. Of course, this is just giving you some of the initial. You can then take that and query in other large language models. Here we're just looking at using CoPilot. So now we want to use the Cusco query language, which was specifically built for Microsoft Azure and obviously made extensively available. So we now want to go ahead and open up our Microsoft CoPilot, where we're looking specifically at that incident. So now we're going ahead saying, okay, well, we need some help. So can you advise the query string that we need to use for us to query the number of successful logons to the host machine? KQL, remember, is literally just like database queries. So if you come from an SQL background, a structured query language background, you'll be pretty familiar with it. This is just for us to be able to extract more information about those specific events. And that's obviously why we can see the introduction of the KQL is very, very advantageous. So we're asking specifically if they could advise us on the syntax. It's now going out there and obviously looking for that information in those large language models, which is obviously using a combination of AI, machine learning, reinforced learning. It's using a lot of various different types of elements to make this information available in text, in audio, and so forth. So here we can actually now see very successful the KQL query to check the number of successful logons to the host machine, and you can actually see the code. So where event ID, where the computer name is. So it's actually formulated everything for us. So this indicates that there were no successful logons to the host machine, and we obviously just validated by repetition, by double checking that, okay, they generate an alert, what actually transpired? Did they gain remote code executed access? And then the final part here is your actual reporting. Remember, your incident response report is critical. If you don't put it in a way that people understand, you shouldn't be doing some of the investigations then, because you've got to investigate all the deep, complex technical mumble jumble, and you've got to put it into a more layman, generic IT person's terminology. It may be also processed by executives. So again, you can see we're now asking CoPilot to write a report based upon the investigation and the actual initial triage in our assessment of the actual incident, as well as the supporting evidence for a great deal of conclusion information, and obviously giving confidence to know that nothing actually transpired. So you can see how it's actually utilizing all forms of evidence we were triaging to obviously then finally put it into an incident response report. This kind of information really is no different to when we were doing it manually, folks, but this allows your threat intel SOC analyst, your incident responders, your entire security team personnel to more efficiently do their job with the assistance of junior assistants, basically in the form of artificial intelligence using CoPilots and its very large language models. You can see how it really made this amazing. Look at the actual structure of the report. So literally this would have taken me, if I did this just on my own without CoPilot, it would have taken me hours. And you can see within a very, very short amount of time, we were able to actually execute our incident response, go through our triaging, validate that there was no serious consequences like a malicious hacker gained remote code executed access, and then finally we've got a brilliant report with recommendations, and even, you know, it says unfortunately a graphic timeline is not available at this time, but obviously this is where it's increasing its capabilities. So as we continue to build our AI machine learning technology in Azure, we're really going to be able to bring technology to the masses and speed up their capabilities.